Okay, hello. So today I'm quickly going to start going over the further maths curriculum for the edXL IGCSE board. So today I'm going to do cubics and then I'm going to do logarithms. So start with cubics. So similar to quadratics, the form of a cubic is ax cubed plus bx squared. This would be not a 6 plus cx plus d equals to 0. It's like a quadratic, it's just that you put in an x to the cube, x3, which is x cubed term, at the beginning. So for example, let's take this cubic. How you would solve this cubic is to begin with, you would plug in numbers such as 0, 1, -1, 2, -2, until you find something which equals 0. In other words, you find some number which is a root of this cubic. In this case, it's x equals 2, which is done just by trial and error in further maths IGCSE. When you get higher up, you will find a formula, but for now, it's just trial and error. Now, the two theorems you need to know is the factor theorem and then the remainder theorem. The factor theorem states that if b divided by a is a root, then ax minus b is a factor. So if x equals 2 is a root, then that means that b over a equals 2, a equals 1, b equals 2. In other words, x minus 2 is a factor of this cubic. So then you put it into this division here. How division with cubics works is it's similar to normal division in the sense of you go, okay, I have x cubed and x. What do I need to do to x to make it an x cubed? Multiply by x squared. And then you subtract this times each of these factors. So x squared times x is x cubed. -2 times x squared is -2x squared. You take this, you subtract this, and you end up with -6x squared. Because minus minus is a positive. And then you repeat. So how many x is going to -6x squared? Well, -6x. Subtract this, and then the -2 times -6x plus 12. You get this final answer, and then how many x is going to -7x? Well, -7. And that gives you your full quadratic. You bring the quadratic, so that once you've done that, you now have this quadratic, and to get from this to this, we divided by the factor, which we determined by trial and error. Then you just bring this one over here, and you simply solve the quadratic. How you solve the quadratic, you can do it any method you like. Normally the quadratic will solve nicely, so you can just factorize, you don't need to complete the square or use quadratic formula, but sometimes you might. But yeah, and then once you got that, you know that your three roots are x equals 2, x equals -1, and 7. For context, a cubic, if the x cubed term is positive, a cubic will look like this. If the x cubed term is negative, it will look like this. The other thing, so on this one, for example, there are 3 roots. But you can also have cubics with 1 root. And sometimes cubics with 2 roots, where this is a recurring root, where it touches it and then leaves again on the same spot where it meets the x-axis. These ones are rarer, but you will see them come up. This you will hardly ever see come up because they want your 3 roots most of the time, in my experience. And then the remainder theorem is similar to the factor theorem, except that so if we assume that f of x equals this function, then f of a is the remainder of f of x divided by x minus a. You can also do b over a instead of a. It's similar to this, you end up with f of b over a is the remainder of f of x divided by ax minus b. ax minus b. But yeah, and you can, if this comes up, it'll be you need to make simultaneous equations and then solve the simultaneous equations. Whereas if factor theorem comes up, this can just be solving a cubic normally. But yeah, that's normally all you'll get in a question. Hope that's